VSEPR theory. It stands for valence shell electron pair repulsion theory. It explains the shape of molecules known as molecular geometry. Valence electrons will repel each other, meaning like charges repel because they're negative, causing them to be as far apart as possible. Bonding positions are based upon how many bonds and lone pairs surround the central atom. Central means center, so we're going to be looking at the center atom very often in this video. For example, water is a bent molecule. So how do we determine the shapes of these molecules? First, you want to complete the Lewis structure, then use the following chart to match it to the correct shape. So something I want to reassure you about is that this little chart will be provided for you. It's not something that has to be memorized, but you do need to know how to use it. So first you draw your Lewis structure. Then we look at the chart to define the shape. So the first column says number of atoms around the central atom. So here is our central atom. It's oxygen, and there are 2 atoms around it. Oftentimes kids will look at how many electrons are around it. No, how many atoms are around the central atom. There are 2 atoms around the central atom. They're hydrogen atoms. So we are looking at this part right now because there are 2 atoms around the central atom. Let's look at the next part. The number of lone pairs around the central atom. Lone pairs are these guys. So there are 2 lone pairs around the central atom. So 2 atoms around the central atom, 2 lone pairs around the central atom tells us that the shape is bent 109.5 degrees. So that would be our answer for the shape of this molecule. Any molecule containing only 2 atoms will always be linear because 2 points make a line. So if you notice that I'm asking you what is the molecular geometry for any 2 atoms like H2, Cl2, HF, it's going to be linear because you've got one atom and then another. The only way to connect them is with a straight line. So that is what linear looks like. Okay, so this part says complete the Lewis structure for the following molecules and then determine the shape. Well, because I taught you how to draw Lewis structures in the last video, you should be a master at this. So pause the video, draw your Lewis structures, then unpause and come back. Do not cheat yourself at this point by just skipping ahead and copying. You're going to miss something. Miss that practice that your brain really needs to do in order to be successful at this. So please draw the Lewis structures first and then unpause the video. Okay, welcome back. I have the completed Lewis structures for each of these molecules. So at this point, we're going to look them up on the little chart and define their 3D shape. So if we look at sulfuric acid, which is our first one here, we have 2 atoms around the central atom. So 2 atoms around the central. Then I have 2 lone pairs. So again, looking this up on our little chart, 2 and 2 is bent 109.5 degrees. Very similar to water. So next to sulfuric acid, please write bent 109.5. Okay, the next one is carbon tetrachloride. So here's our central atom. We have 4 atoms around the central atom, and there are 0 lone pairs. So 4 and 0, let's look it up on the chart. 4 and 0 is called tetrahedral. So the shape of this molecule is tetrahedral. Okay, BF3, so boron trifluoride. Boron has 3 atoms around it and 0 lone pairs. So looking it up on our chart, 3 and 0 is trigonal planar. Silicon dioxide, so around silicon I've got 2 atoms and 0 lone pairs. So 2 atoms with 0 lone pairs, this one is linear. Next, we've got ammonia, which is right here. I've got 3 atoms around our central atom with 1 lone pair. So 3 and 1 is this guy. It's trigonal pyramidal. So we can see boron trifluoride and ammonia are different. One is trigonal planar, the other is trigonal pyramidal. And when you build these in class, you'll see that trigonal pyramidal kind of stands up in the center or it's lifted. Trigonal planar lays flat. Planar, it lays flat on the plane. So when you build these, it's important to look at the difference between the two. So this little lone pair being present actually causes it to be a little bit lifted in the center. Okay, lastly, we've got sulfur dioxide. So sulfur is our central atom. There's 2 atoms around it with 1 lone pair on our central atom. So we're looking at a 2-1 here. So 2-1 is bent 120 degrees. Okay, I hope you enjoyed today's video over VSEPR theory. Go ahead and go to your practice packet and practice figuring out the 3D shapes of these different molecules. We're also going to build these in class, which I think you'll enjoy. Have a great day. Don't forget to ask your teacher if you have any questions.